Hi, hello, how are you students? I hope all of you are fine and I wish that. Okay, in this session we are going to discuss about Theorem 1.3. Okay, prove that root 2 is irrational. Okay, so we all know root 2 is irrational number, right? But for finding solution in this exercise, we are going to assume something against the fact. Okay, that means the irrational number we are going to assume like a rational number. Okay, and then we will work out the solution and prove that our assumption is wrong, so that root 2 is irrational, like that. Okay, so this method is called as contradiction method. Okay, what is contradiction? Something against or something different than the proven fact. Okay, so root 2 is irrational number, it's a proven fact, but we will assume that root 2 is a rational number and we will start the exercise. Finally, we will conclude that our assumption is incorrect, so that root 2 is irrational, like that. Okay, let's start the solution. Okay, now to the contrary, let us assume root 2 is rational. Assume root 2 is rational. Okay, right. All of you know any rational number can be expressed in the form of a divided by b, right? So we can write root 2 is equal to a divided by b. Okay, where a and b are integers and a and b are co-prime numbers. Okay, we can write where a and b are co-prime numbers. Okay, so what is co-prime number? This is very important assumption in this exercise, and we are going to prove that these a and b are not co-prime numbers. Okay, so you should know first what is co-prime number. Co-prime number is a pair of numbers. Okay, and a and b are not having any other common factors except one. Okay, so there is a scroll up video about prime numbers, composite numbers and co-prime numbers. You can scroll up and see that video, so that you will have better idea about co-prime numbers. Okay, now let's square both sides. Okay, squaring both sides. So root 2 square is equal to a square by b square, right? So root 2 square is 2 is equal to a square by b square, right? Now we can write 2b square is equal to a square. Okay, and we will keep this equation as 1. Okay, now from this equation we can write b square is equal to a square by 2, right? Now 2 divides a square, right? So as per the theorem 1.2, if any number divides a square, then that number will divide a also, right? So we can write here, as per theorem 1.2, if 2 divides a square, then 2 divides a also, right? So hence 2 is a factor of A, right? So from this what we have done is 2 is a factor of A. We have proved this. Okay. Now our aim is, we assumed A and B are co-prime numbers, right? But we found one more factor, 2 is for A, right? So 2 is a factor of A, we proved. And the next step, we are going to prove 2 is a factor of B also. Okay, let us see that. Now we can call it as step 1. Okay, this is the first step. Now coming to step 2. Okay, you see here, we have already concluded as per the theorem 2 is a factor of A, right? So if 2 divides A square, then 2 divides A also, right? Now we can write A by 2. Okay, we don't know the answer, right? So we can assume the answer is C, where C is an integer. Okay, you can write here where C is an integer. Okay, from this we can get A is equal to 2C. Okay, so let us keep this as equation 2. This is 2. Okay, we have first equation, 2b square is equal to A square. Now we have another equation, A is equal to 2C, right? So we found the value of A. Okay, now we can apply the value of A in this first equation. Okay, we can take this as step 3. Okay, in the third step, apply 2 in 1. Apply the equation 2 in the equation 1. Okay, so the equation 1 is 2b square is equal to A square. Right here, 2b square is equal to A square. Right, now the value of A is 2C. Right, we can apply the value of A in this equation. 2b square is equal to 2c the whole square. Okay, so 2b square is equal to 2c whole square. Okay, so now 2b square is equal to 4c square, right? So bring this 4 this side. 2b square divided by 4 is equal to c square, right? So here 2 one time, 2 2 time here. So we can write c square is equal to b square by 2. Dear students, so here 2 will divide b square. We concluded. Okay, you can see here in the first step 1, we concluded that 2 will divide A, right? Here we are concluding 2 will divide B. Okay, so now we can write as per the theorem 1.2, if 2 divides B square, then B will divide 2 also. Hence 2 is a factor of B. Okay, we can write here as per theorem 1.2, if 2 divides B square, then 2 will divide B also. Hence 2 is a factor of B, right? This is a conclusion. Okay, in the first step we have concluded that 2 is a factor of A, and in the third step we have concluded 2 is a factor of B, right? Which is against our assumption, because we assumed A and B are co-primes. Co-primes means A and B are not having any other common factor except 1, right? But We proved here 2 is a common factor of A and B, right? So this is contradiction to our assumption. Okay, this result happened because our incorrect assumption of root 2 is a rational number. You see, let's assume root 2 is a rational number. Because of this incorrect assumption, this result happened. Hence, root 2 is irrational. We have to prove like that. Okay, now we will write the answer. So now we can write our conclusion. Okay, then put here conclusion. Since 2 is a common factor for A and B, A and B are not co-prime, which contradicts our assumption. This happens because of our incorrect assumption of root 2 is rational. Okay, hence root 2 is irrational. That's all, students. Okay, so as a summary, as a nutshell, what we have done. First, we assumed root 2 is rational number. Okay, so if root 2 is a rational number, it can be written in the form of A divided by B. Okay, so we put root 2 is equal to A divided by B. Okay, and squaring both sides, we found A 2B square is equal to A square. Okay, keep that equation as equation number 1. Okay, and then from that we are finding the B square is equal to A square divided by 2. When you find B square is equal to A square divided by 2, it is clear 2 is a factor of A square. As per theorem 1.2, if any number divides A square, that number will divide A also, right? So we can write A by 2 is equal to C, some unknown number we are keeping here. We are bringing this to step 2 and we are arriving A is equal to 2C and keeping as equation number 2. And then in step 3, apply equation 2 in equation 1 and find out C square is equal to B square by 2. Okay, so here B square is dividing 2. 2 is a factor of B square, hence 2 will be a factor of B also. We are proving that. Okay, in step 1 we are proving that 2 is a factor of A, and then in step 3 we are proving that 2 is a factor of B. Okay, so A and B are having a common factor 2, which is against our assumption that A and B are co-prime numbers, right? This incorrect assumption happens because we assumed root 2 is rational. Okay, hence root 2 is irrational. Clear, students? We can conclude like that. Okay, thank you. See you in the forthcoming lessons. Bye bye.